All right, good morning. Welcome back to trigonometry. We are continuing to show how to graph some functions here. So this one I picked up. I said y is equal to -2 cosine quantity 3x minus 5 and all minus 1. So it's got all the different elements in it. We have an amplitude of 2 here. Because remember, it's always the absolute value. So the amplitude of this function is going to have a absolute value of -2, which is going to be 2. The negative out in front is a reflection about the x-axis. So we're going to have, instead of the cosine looking something like this, right? The cosine is going to flip and it's going to look something like that. Okay, so we have to remember it's going to go upside down. We have a phase change here and we have a phase shift here. Okay, so we have a period change. Sorry, not phase change, period change. We have a phase shift and we have a vertical shift here, -1. So there's all the different elements. So we're going to go ahead and figure out how to graph this thing. The first thing that I really care about is this stuff in the middle here. Like that's, going to take up most of my energy for being able to graph this thing. And when I'm looking at this, like again, there's the anchor points. Like I want to hang my graph on a couple of different points as we're going through this, right? That's what I'm kind of looking for. So we're looking at 0. We're looking at pi over 2, which should be pi over 2. We're looking at pi, 3 pi over 2, that's the 0 here. And then finally 2 pi that's when the graph finishes and we get to repeat it. So those 5 points are the ones that I really care about. Because again, when you write this problem for an exam, and when you guys are doing this problem as an exercise, it's going to say something like note 5 points on the graph. They might indicate like note your intercepts, note your maximum, note your minimum. Okay, they'll specify the kind of points they want. I don't just want you to say, well, x equals 1, 2, 3, 4, 5, and have you just plug those into a calculator and give me, those random points as values. I want you to do specific points. Okay, so those are the anchor points that I use to show you where to hang the graph from. Okay, so let's go ahead and start figuring that out. So what we have to do is we have to figure out what does x have to be so that 3x minus 5 is equal to 0. That's not too bad. We actually have to do this for 5 points. We have to say 3x minus 5 equals pi over 2. 3x minus 5 equals pi. 3x minus 5 equals 3 pi over 2. And 3x minus 5 is equal to 2 pi. Okay, again, there are other ways to do this. This is the way I like to do it because it cuts down how much stuff I have to memorize. Solving five linear equations never struck me as, I mean, when I was learning algebra, yeah, this was a task. But by the time you make it to trig, solving five linear equations, that's not a scary thing to have to deal with. Okay. So we go ahead and solve this. We have 3x is equal to 5. We just added 5 to both sides. And then we say that x is equal to 5/3. That's my first point. Hold on to this guy because there is going to be a pattern. There's always a pattern. But the first point usually doesn't help you figure out that pattern because there's no weird numbers on the right-hand side. Like pi over 2 is the thing helps. You don't even have to go in order. I'm not going to go in order for this one. We're going to say 3x minus 5 is equal to pi. We'll do this one. So I have 3x equals pi plus 5, and it will divide everything by 3. And we'll say, okay, this is x is equal to pi plus 3 all over 5. Okay, you can say it's pi over 5 plus 3/5. That's fine. But we can just leave it like this, and then we'll go ahead and do it that way. Okay, what's the last one? 2 pi. So we have 3x equals 2 pi plus 5. I just added 5 to both sides again. So we have x is equal to 2 pi plus 5 all over 3. I messed up a little bit on this one. Okay, serves me right for not doing anything before I drank the coffee, or serves me right for trying to do this before I got the coffee. Let's rephrase this guy right here. We added 5 to both sides. That stays a pi plus 5. Divide both sides by 3. Okay, so as I'm looking at this problem, I'm thinking to myself, there's probably some kind of a pattern that involves some kind of a something plus 5 divided by 3. Don't answer yet because when we get to the pi over 2's, it's going to change a little bit. We're going to have to adapt this. Right now, the thing I'm looking at the beginning, I could say this is 0 pi, right? That would still say 0, plus 5 divided by 3. Okay, but we're not quite ready to have a pattern just yet. Let's do the two ones in the middle, the pi over 2 and the 3 pi over 2, and see if we can't get those guys to be done first, and then we will have a pattern. So let's go ahead and add the 5 to both sides. We have 3x equals pi over 2 plus 5. Well, we can't wander around without having, we have to get common denominators here, all right? So how do I get common denominators here? I'll multiply by 1. Two tricks in math. Multiply by 1 and add 0. So we're going to say this is pi plus 10. Now that these have common denominators, we can go ahead and scoot them all together. And this is still equal to 3x. So my final answer here is going to be pi plus 10 divided by 6. That gives me a little bit of an indication of like, what am I going to have to do here? I think I'm going to have to multiply this stuff by 2 over 2 to get 0 pi plus 10 all divided by 6. This is 1 pi plus 10 divided by 6. Let's go ahead and deal with this one. If I change this one to 6's, we're going to end up with 2 pi plus 10 divided by 6. And I will bet that if you're going to feel like Dora the Explorer again, right? Do you see a pattern yet? I'll bet you do. So we can look at this 0 pi plus 10 over 6, 1 pi plus 10 over 6, 2 pi plus 10 over 6. I wonder if we're going to have a 3 pi plus 10 over 6. We're going to go ahead and solve this thing. Add the 5 to both sides. We have 3x is equal to 3 pi over 2 plus 5. But again, we're not going to just leave it like that. We're going to get common denominators, right? Like we're supposed to. So we have 3 pi plus 10, x equals 3 pi plus 10 all over. We're going to divide both sides by 3 here. So divide by 3 over 2. 2 times 3 is 6. So we end up with 3 pi plus 10 all over 6. And then we're all over 6's, so let's go ahead and make everything over a 6. So we end up with a 2 times both of these quantities, 4 pi plus 10 divided by 6. So I did this problem by figuring out my 5 linear equations. I verified it by checking to see there was a pattern, and everything is falling in line with the pattern. Okay, so that's how you go ahead and generate your anchor points. And that's like the major part of being able to do this graph. The reason why I kind of noted the negative here is because I will forget the beginning part of this graph by the time I get to the end. You should do that. But that's what happens. Okay, so let's go ahead and we're going to go ahead and graph this thing. So we have this piece, and I'm going to go up here. Well, yeah, here's my 0. There's a vertical shift here of a -1, right? So I'm going to go ahead and draw myself another kind of little axis here, y equals -1 here, because instead of dancing around the axis, it's going to dance around y equals -1 because it's a shift down. And then we're going to go ahead and say, okay, we have 2 points here. So let's see what 2 points we have. We have 0 pi plus 6 all over 10. So we can say this is 0 pi plus 6 all over 10, which my last point is 4 pi plus 10 all over 6. And I'm not really looking for the exact scaling for this thing. If you need the exact scaling, we'll do one more step where we would punch these things into a calculator and kind of get a better idea of what the scale is. Or because we live in the 21st century, we'll plug it into Desmos and have Desmos do it. So depending on who your audience is for, if it's for like I've got to wrap this thing on an exam, I don't really care so much about the scaling for this thing. Okay, I want you to be able to graph these points and find out where these points should be. If we've got if we got a more formal presentation, maybe I'm putting this together for people who are not so good at reading math and have a little bit of trouble with it, I'd probably replace these with decimals. Okay, but that's the second step. Okay, the next thing we're going to do is like, okay, well, where's my middle point? And that was when we were equal to pi. So it's going to be 3 pi plus 10 over 6. So right here, the middle point, 3 pi plus 10. Well, Is it over 6? It's yeah, we're all over 6. So that's going to be 3 pi plus 6 over 10. Okay. What is my not over 10? What am I doing? 3 pi plus 10 over 6. Again, I did it. So let's scratch that. Let's scratch this. All right, let's change that. So we have 3 pi plus 10 over 6. There we go. That's better. And it was my first point was pi plus 10 over 6. Okay. So here we have pi plus 10 over 6. I'm going to double check this guy right here. This was a 2 pi plus 10 over 6. Man, oh man. All right. This was a 2 pi plus 10 over 6. I'm just doing everything wrong tonight. Okay. So we have 0, 1, 2. I bet this one's going to be 3 pi plus 10 over 6. See, those patterns do save us a bit. Okay. And then now we're going to be able to say, we're going to dance around this line y equals -1, and then how many steps are we taking from that in order to do our little thing here? We're going to take 2 steps because we have an amplitude of 2. So we really have to come down here and say, okay, -1 minus 2 more, we have -2 minus 3. We're going to go up 2 because we're going to say -1, 0, 1. Okay. So as I'm looking at this graph, we have a point here. It hits the 0, which is really y equals -1 here, right? And then we're going to be going to our maximum, which is going to be 1 for this piece right here, down, and then back here again. So when I'm going to draw my cosine in here, right? I did a terrible job drawing this. I'm trying to get this thing where it's knowing that, again, this is going to keep going on and on and on. This is going to keep going on and on and on. There's an obvious pattern here that somebody could say, okay, we have 1 pi over 10, 2 pi over 10, 3 pi over 10, 4 pi over 10, 5 pi over 10, 6 pi over 10, 7 pi. This pattern can go off to infinity. We could go off to infinity in the other direction so that we would be able to graph this thing as far out as we wanted. But this is the kind of graph that I'm looking for. And what I'm trying to grade on you guys, when you're demonstrating you can do this, is did you get the intercepts correctly? Did you get the maximum point correctly? Did you get the minimum points correctly? When I say intercept, I mean adjusted intercept. Okay, like we have the -1. We are not to the point where you are setting this equal to 0 and solving. Okay, that's common, but we're not there yet. So I don't really mean these points. I mean the points where it intersects the y equals -1, where it intersects the vertical shift. Okay, so we'll say adjusted intercepts. We're not here yet. We are not trying to find those 2 points. We will get there, but I'm looking for this point and that point. All right. So I think that is a good demonstration for what we're trying to do here with a little bit of mistakes in there with me misstating like some problems, some numbers, but I think that does it, and it gives you a good idea of how to do this. I'm going to say thank you very much for watching the video, and I will see you on the next one.